Here's the guide for factoring polynomials. We need to start with the common monomial factoring. Then whatever will be the result, we're going to categorize them as to whether the result is a binomial, trinomial, or multinomial, and we have specific processes under specific results. Then we end it. Let's start with this polynomial. This is a trinomial. And based on our guide earlier, we could look into the relationships for the terms here, whether this is a perfect square trinomial, or it could be factorable when it comes to looking for two different binomials. But before we go to that process, the first step that we need to do whenever we factor things like this is to consider the presence of common monomial factors, or the greatest common factors. Well, if there is no greatest common factor, then we can proceed with whatever steps you would like to. But here it's very obvious. Look at the three terms. Now, the numerical coefficients might have no other factors aside from 1, because the first numerical coefficient here for the first term is 1. In this we have 3. And that's 1. So the greatest common factor is just 1, so we don't need to worry about that. But for the variables or the literal coefficients, noticeably, all of them are with variable x of different exponents. And remember, exponents is a sign of the number of the same variable that is multiplied by each other. So we can have a common factor here. The common factor is for the literal coefficient, and that's x. But that is not just x, because if you do take x here, when you divide the first term by x, you will still have x to the power of 4. Okay? X to the power of 4. If you're going to divide the second term with x, you will still have x cubed. And for your third term, if you're going to divide this by x, you will have x squared. This would mean that we can still factor another x. And there is also another x for that. This would mean that we are not going to factor only x. We are going to factor x with the least exponent. And we're talking about this term here. So we're going to have x cubed. Why least number of exponent? Because this has x cubed. Your second term is also an x cubed times x. And your first term is x cubed times x squared. So all of these three terms has x squared, x to the power of 3, or x cubed. So when you're done with that, let's try to determine the remaining trinomial. So x to the power of 5 divided by x cubed, you will have x squared. Again, you can also verify that when you multiply, you add the exponents, 3 plus 2, you will get 5. For the second term, it's still minus 3 for the numerical coefficient because you did not take any other factors except for 1. But your literal coefficient is now x to the power of 1, or x, simply x, because that's x to the power of 4. X to the power of 4 is x cubed times x. And of course, if you would like to, you can still verify this one here in checking. X cubed times x is x to the power of 4, and still you have negative 3, so this is still correct. While your last term, since you divided x cubed with this term, you will get 1. Okay? It's not 0, it's 1. And if you're going to check that again, when you multiply that, you will get x cubed. So this is now the process after taking out the greatest common monomial factor of x cubed. Now let's look at our trinomial. After the first step of the common monomial factoring, this is a trinomial, so it could, or the next step rather, could either be checking whether this is a perfect square trinomial, or we could have another steps in factoring this. Now those two hints can be verified with this. For perfect square trinomial, the first term and the last term should be a perfect square, and it meets the criteria. X squared is a perfect square. 1 is a perfect square. But there's also the criteria. The middle term should be twice the square root of first and third term. The square root of x squared is x, so it's here. Good. The square root of 1 is 1, but this is not twice, this is thrice. Therefore, this is not a perfect square trinomial. Discussions to that will be on different examples soon. The second trinomial that we are going to consider is whether we could look for another way to factor this trinomial. We could do that by looking at our C. The factors of 1 is 1 in itself, or 1 and 1. We could say that there is another factor for this if we could look for factors of 1 that when added will result to negative 3. Again, the factors of 1 is just 1 in itself, or you could also use negative 1 times negative 1. But those pairs, when added to each other, will not get negative 3. In short, this is also a non-factorable trinomial. This means this is not the final answer. Again, the consideration there is, yes, we have a trinomial, and we need to examine further if the trinomial is still to be factorable. But in this case, it cannot be. So this is now the factors of x to the power 5 minus 3x to the power 4 plus x cubed. It's x cubed times the quantity x squared minus 3x plus 1. The next factor we're looking for is for our next subscriber. Subscribe now!